so we have a force is applied horizontal to a block to move it up a 30 degrees incline. The incline is frictionless. It says if F is equal to 50 newtons and the mass of the block is 6.5 kilograms. Part A wants us to find the magnitude of the acceleration of the block, and then part B wants to find the magnitude of the contact force F of n. Okay. All right, so let's go ahead and crack this out. Before you start doing A and B, it's wise and highly suggest that you draw your free body diagram out. So I'd like to remind you that for these types of incline problem, it is easiest to treat the surface of the incline as your x-axis. We like to call that the line of motion to be our x-axis, and then perpendicular to that would be your y-axis. Okay. Therefore, now I'm going to draw my free body diagram. The block has a mass m, so it has to have a weight, or in this case, the force of gravity, which is mass times g, or mass times acceleration due to gravity. But you notice here, this f of g lies in between the y and the x-axis, so it has to have components. Well, if f of g lies in between x and y, it has component f of gy. So I'm just going to do f of gy first here. F of gy is pointing down along the y-axis, because if you start from m, you got to go down along the y-axis and then down along the x-axis to get to the end of the arrow here. All right, so make sure you draw your components carefully. So f of gx here parallels the surface of the ramp. Okay, make sure when you draw f of gx that it parallels the surface of the ramp, this blue line that I have on my picture. Okay, so don't just draw it straight across the page, because if you draw it straight across the page, it will actually intersect with the x-axis, which means it's not parallel. That's how you know you're doing this stuff wrong. So make sure you take a second, draw f of gx parallel to the surface of the ramp, and f of gx will always point down the slope. Okay. All right, other than that, let's go ahead and place the 30 degrees there. The incline is 30 degrees, so that's also 30 degrees. Here that just popped up, y is pointing leftward, but leftward now lies in between, once again, the y and the x-axis. So I like to reference that as a diagonal, because it is a diagonal. In this case, your hypotenuse, it has to have components. This would be f of y. F of y must point down, because if you start at the beginning of the arrow, it has to go down and then up in order to meet the ending point where the arrow is. Okay, so f of x must point upslope. All right, why I know the problem states that it is going to move up a 30 degrees incline. Okay, I want to just kind of show you how to solve it if it doesn't explicitly states that it moves up the incline. Sometimes it can actually move down depending on the magnitude of this force that's being applied here. So if this force is weak, the weight of the system can actually go down slope rather than going up. So try not to carry over any misconception. This one tells us it's going to move up, but I'm going to show you how to run a quick test in case it doesn't say up or down. All right, so last but not least, Fn is drawn along the y-axis here, and that's that. Okay, and I drew Fn, by the way, hold on, let me just point this out. I drew f of n longer than f of gy and fy because if you look at this diagram, you have two arrows pointing down the y-axis, which is f of gy, and then fy, which is also pointing down along the y-axis. But fn is the only arrow pointing up along the y-axis. But we know that the forces up along the y-axis must equal to the forces down the y-axis. So I know fn must be greater than f of gy, and it must be greater than f of y. So it actually is the sum of these two vectors, f, gy, and fy. So just for technicality, I drew fn a little longer. Okay, all right, but once again, as I said earlier, to show you how to run a quick test in case it does not tell you whether it moves up or down, again, you cannot assume that it moves up just because you're pushing up. Okay. Well, I can find f of gx real quick. If you look at this diagram, there are two arrows pointing along the along the x-axis. F of gx will always point down slope. F of x in this problem points up slope, right? Well, how do you know if it moves up slope or down slope? Well, just run these quick tests. Find the value of f of gx. In this case, f of gx is just mass times gravity times sine at 30. It's sine because f of gx is the opposite leg of this angle that's between the f of gy and f of g. So if you've done a bunch of incline problems, you know that f of gx is always going to be mg sine theta. So plugging in mass is 6.5, g is 9.8, sine at 30. And then if you plug in your calculator, you get f of gx, which is equal to 32.7 newtons. And that's just the magnitude. How do you know if it's moving uphill or downhill if it's not stated for you? Well, run a test. This is how you run a test. Okay, I can find this fx too. Well, f here is my hypotenuse because this is the right triangle. Fx though touches the angle that's given to me in the diagram. Because the angle here touches the x-axis, fx is cosine, fy is sine. So here I have fx is f cosine 30. F being 50, newtons because it sets it on the problem, and then cosine of 30. So if you punch in 50 times cosine of 30 on your calculator, you get that the magnitude of f of x is 43.3. Once again, I know the problem says that it already moves up the ramp, right? But in case it doesn't say so, you cannot assume that it moves up. You need to run a test to see if it moves up or down. In this case, using common sense, fx is 43.3, which is greater than 32.7. So I know that this is going to move up the ramp as stated in the problem. If you find, let's say for example, if you give another problem, right, and you find fx and fx is smaller than 32.7, then it would tell you that it actually accelerates down the ramp. Okay. All right. Other than that, let's go ahead and crack out part A. Part A wants to find the magnitude of A. Well, we already know that's going to go upslope, right? So therefore, we know that fx is larger than f of gx. So I'm going to take the big f of x here. I want to subtract it from f gx, which is acting against it. So fx points to upslope, f gx points downslope. That would be opposite direction. So I will subtract. That equals to max. Well, we already know the values. fx we already calculated, which is 43.3. fgx we calculated was 32.7. I'm subtracting because they're acting against each other. Mass being 6.5, and then ax is the only thing that's left unknown. The difference on the left side will give you 10.6, and then to find ax, divide both sides by 6.5, and then if you do that with a calculator, you should get a magnitude of about 1.63 meters per second square. So that is the answer to part A. Part B wants to find the magnitude of f of n. Well, because it's f of n, you need to focus your attention now along the y-axis. Once again, fn lies along the y-axis, fgy lies along the y-axis, fy lies along the y-axis. So here we have three arrows that we need to compensate for. Here, I'm just going to start with the same thing. Net force in the y direction is to go to m times acceleration in the y direction. As I counted earlier, fn is pointing upward along the y-axis, fgy is pointing down the y-axis, fy is pointing down along the y-axis. So here, fn is positive. I want to subtract it from the two arrows that is opposing it. I want to set that equal to ma, but acceleration in the y direction for inclined surfaces is 0 because the block is assumed to stay on the surface and not fly off in any way, shape, or form. So ax needs to go to 0. All right, so mass times 0 will give you 0. Here, the left side I kept the same, so I'm just doing step by step for you. To solve for fn, I want to move negative fy, negative fgy to the right side. So fn is going to equal to fy plus fgy. Okay, so don't forget to change the sign of these variables as you move them to the right side or left side of the equal sign. All right, it went from negative to positive. Here, fy, once again, if you go back to the diagram, fy here is the opposite leg of this angle. Opposite in this case would be sine. So it would be f sine 30. And then f of gy, similarly to f of gx, if f of gx is mg sine theta, f of gy would be cosine. It's cosine because f of gy is the adjacent leg to this 30 degrees angle that touches fgy and f of g. Okay, so make sure you get your sine and cosine right. Okay, if you don't get them right, you're gonna make a doable task into something that's difficult. All right, so here, if you plug in f as being 50 because it said so, sine of 30 is a half of 50 is 25, then 6.5 times 9.8 times cosine of 30 will give you about 55.17 in your calculator. If you add those two values up, it tells you that Fn is equal to about 80.17 newtons. Okay, and that is the magnitude. Both A and B ask for magnitude, so I will leave it as that. And that is it for this one. All right, so be careful with your sine and cosine. Stay nerdy, don't be whack.